Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good afternoon to all of you. Thank you for joining the class this afternoon. So we are going to continue our dynamics lesson. We are currently in chapter 2 where we discuss about the equation of motion, and today we are going into a new subtopic, that is the normal and tangential components of equation of motion. So if you recall, last week we have covered the first subtopic of equations of motion, that is using rectangular component. Rectangular component means the normal, the standard x, y, z coordinate system, where we use these rectangular components for rectilinear motion. And today we are going to continue our lesson, um, in which we will discuss problems related to curvilinear motion, where we need to apply normal and tangential components instead of the rectangular components that we have discussed last week. So let's look at the lesson outcomes for today's class. So at the end of this class, you should be able to understand when to use the NT coordinate instead of rectangular coordinate. Okay, and then we should recap or refresh our memory on the formulas related to tangential acceleration AT and also normal acceleration AN. And finally, we will be looking at using the NT components to solve some problems related to kinetics of particles. Okay. Let's recap a little bit about the inertial reference frame. So last week I have mentioned about this. Whenever we want to apply the equation of motion, we need to have inertial reference frame. It may sound confusing. What is inertial reference frame? It is basically the coordinate system lah. So whenever you want to apply the equation of motion, it has to be based on coordinate system. So it can be the usual XY coordinate system, or like what we are going to discuss today, we will use the normal and tangential coordinate system. So basically, the inertial reference frame, we can divide into three, like what we have covered in kinematics chapter 1. So we have three types of coordinate system that we can use depending on the situation that we are facing. Okay, kalau the motion involve rectilinear motion, which is the path of the motion is in straight line, we will use rectangular coordinate, the usual, the normal XYZ coordinate. If we have curvilinear motion, like what we are going to discuss today, we are going to use normal and tangential coordinate. And sometimes if it involves helical motion or curvilinear motion in three-dimensional, we will use cylindrical coordinate, which we will cover in the next class. So today we are going to focus on the normal and tangential coordinate system. So this is what we have covered last week. Basically, when we are dealing with equation of motion in rectangular coordinate, then we have three equations that we can use, or normally when we are talking about problems in two-dimensional, most of the problems that we discuss in this class is two-dimensional problem. So we are going to focus only on x and y axis. So we're going to have the equation of motion F equals to ma in x-axis, that is total force in x, or sum of fx is equal to max. and sum of Fy is equal to MAY. This is for rectangular coordinate. So we are going to do the same for today's class, whereby we are going to replace the XY axis here with normal and tangential axis. So the rectangular coordinate that we discussed last week is used for rectilinear motion, motion in straight line path. But for curvilinear motion, we are going to use the normal and tangential coordinate. So if you remember, if the motion of a particle is in a curvilinear motion like this, then we can define the coordinate system using normal and tangential coordinate. So tangential coordinate will always be tangent to the path. Okay, if you look at the path here, so tangent to this path at this current position of the particle will be pointing in this direction. This is tangent, and the normal axis will be 90 degrees to the tangential axis and pointing towards the center of the arc. Okay, center of the arc is point O here. So these two will make a 90 degrees angle, normal and tangential axis. So the tangential axis is always tangent to the path. The normal axis will always point to the center of the circle. Okay, this is the circle of the portion of this curvilinear path. So this center point of the circle will be where the normal axis is pointing towards. Okay, so that is what we have learned in the first chapter in kinematics. So basically, we are going to use the same knowledge that we have learned in the first chapter, normal and tangential coordinate, and now we are going to apply the equation of motion in terms of normal and tangential coordinate. Okay, so like what you have before, fx and fy, now we have sum of ft, the total force in tangential axis is equal to mat, okay, and also the sum of forces in normal axis fn is equal to man, the mass times acceleration in normal axis. So basically these are all the same. It is still using the Newton's second law of motion, which is F equals to ma. The thing that is changing is only the axis. Okay, the axis previously we use x and y. Now we use tangential and normal axis. Okay. When we look at the normal and tangential axis in three-dimensional, this one I have not yet covered in kinematics, but it is good to know. Although I can tell you that most of the problems that we are going to discuss or solve in this dynamics course will be two-dimensional. But just for your knowledge, if the tangential axis is pointing in this direction, tangent to the path, and normal axis is pointing towards the center of the arc, then for three-dimensional, there will be another axis pointing up here, which is 90 degrees to t, 90 degrees to n. This is called the binormal axis. This is normal axis pointing to the center of the arc, and the axis pointing up in the z direction. If you imagine x, y, z coordinate, so the binormal axis is basically representing the z coordinate lah, z axis. So binormal axis B, what it tells you is that there is no motion in binormal axis. Okay, there is no motion in binormal axis, which means that AB, if you take the binormal axis here, the acceleration in the binormal axis, there is no acceleration in binormal axis, which means that AB equals to 0. Therefore, the total force in the binormal axis will be always equal to 0. Okay, this is just for your knowledge lah. but most of the time we will focus on these two equations or formula: ft equals to mat and fn equals to man. And if you recall from the first chapter, we know that at, the tangential acceleration, is equal to v dot or dv over dt. So we can rewrite the equation ft is also equal to m times v dot. And for the normal component of acceleration, an is equal to v square over rho. Okay, this is one formula that you should remember. V square over rho. V is the velocity of the particle. Rho is the the radius from the particle to the point of to the center point of the arc, the center point of the path. So in this case, the rho is the distance from P to O. Okay, that is the value of rho. So sometimes rho can be given in the question, sometimes we have to calculate the value of rho. So this is basically all the things that you need to know for this subtopic. So ft is equal to mv dot. V dot means dv over dt. Okay, and fn is equal to mv square over rho. And then for the binormal axis, the three-dimensional axis pointing up, there is no acceleration in this axis because the acceleration is always happening in the normal and tangential axis plane only. This plane of normal and tangential axis, it is called the osculating plane. So there is no motion in this in the binormal axis. It is only a planar motion on tangential and normal axis. So therefore fb is equal to 0 because ab is equal to 0. Okay. So the procedure of analysis for normal and tangential component is almost similar to rectangular component. First, you will define the anti-coordinate system. Okay, whenever you start with the calculation, always define where is your positive direction of tangential and where is the normal axis is pointing towards. Okay, so that is very important. And then you need to draw the free body diagram showing all the external forces acting on the particle. Why this is important is because I have explained also in the previous class, if F equals to MA, then the free body diagram will show what is on the left hand side of the equation, which is the F, the total force on acting on the particle will be shown in the free body diagram. Okay, that is why free body diagram is very important. And to represent the right hand side of the equation, you draw the kinetic diagram, which is showing the particles inertia forces. Now is MAT and MAN. In the previous class, we showed the inertia forces in terms of X and Y axis. For this subtopic, we are showing MAT and MAN, tangential and normal components. And the particle's normal acceleration always act in the positive n direction. So there is no way the normal acceleration is not pointing towards the center of the arc. The normal acceleration will always point to the center point of the arc, which is the point O just now that we have shown in the previous slide. Number 5, if the tangential acceleration is unknown, you may assume that it is acting in the positive direction of the tangential axis. Okay, so this is one of the assumption that you can make in the calculation. And if you get a negative answer, which means that your assumption is wrong, and the direction of the force, sorry, the direction of the acceleration will be in the other way around. But that is not a wrong answer. You can always write the negative sign to show that to show the direction of the acceleration. Okay. Like I have mentioned just now, AT is equal to V dot, which is dV over dt. And then we have our basic kinematics equation. We can then apply A ds equals to V dV, or in this case, it is AT ds equals to V dV. To solve the problem, if this is needed, then you have to apply this basic kinematics equation lah. And then for an is equal to v square over rho, like I have explained before. And if rho is unknown, and if the function of the path is given, then we can calculate the value of rho, which is equal to this formula, 1 plus dy dx square, this whole thing to the power of 3 over 2, divided by the modulus of d2y over dx square. Modulus here means that if you get d2y over dx square is negative, then you can ignore the negative sign because you have the modulus symbol here. This straight line here showing that this is a modulus, or the absolute value, which means that you can ignore the negative sign for to put the value in this equation. Okay. So basically that is all about the theory of normal and tangential equation of motion. Do you have any problem before we continue with some examples? Do you have any question to ask?
I understand, sir.
Okay, yang lain? Ada yang ada soalan? Do you have any question to ask before I proceed with some examples? Clear semua? Okay. So if clear, then let's look at an example. Example problem 1. Okay. Let's read the problem first. If the 10 kg ball has a velocity of 3 meter per second when it is at position A. Okay, let's zoom out. Okay, at current position, the ball here is connected to a fixed point at point O through a cord here, a cord, okay, a rope or a cord. 10 kg ball, it has velocity of 3 meter per second in this direction, tangent to the path. Remember, the velocity is always tangent to the path. When it is at position A, this is position A, given angle theta is 45 degrees, determine the tension in the cord and the increase in the speed of the ball at this position. Increase in the speed means the acceleration of the ball at this position. So the question asks us to calculate what is the tension in the cord, in the rope at this moment, as well as what is the acceleration of the ball at this moment. Okay. So what do we do first? First, we need to define the coordinate system and draw free body diagram. Okay, so let's draw the free body diagram of this ball. I'm going to zoom in here. So what force do you think is acting on the ball right now? How many forces do you think is acting on the ball? How many forces? Can I call a name? Haziq Nakiuddin. Apa force yang ada pada ball ni? Haziq ada? Or anyone else?
Tension, gravity,
Tension and
gravity.
okay, let me correct you. Gravity is not a force. Gravity is the acceleration, but the force acting on the ball is the weight. Weight apa berat bola tu ialah satu bentuk force yang sedang bertindak ke atas dia. Tapi gravity is not a force, but the weight can be calculated as m times g. So gravity dekat sini, gravitational acceleration g. M times G will be equal to the weight of the ball. Okay, so this is one of the forces acting on the ball, and the other one, correct. Our friend has told us that there is a tension. Tension ni mesti point towards the center of the ni lah apa dekat mana tali ni kita ikat the center there the tension will be pointing towards that. Okay. So these are the two forces that is currently acting on the ball. Alright. So sekarang ni kita nak cari okay, before we continue, we need to define where is our tangential and normal axis. Okay, siapa boleh bagi tahu saya tangential axis is pointing in which direction, normal axis is pointing in which direction? Come on. Tangential axis is pointing in which direction?
Axis is parallel to the velocity.
Okay, good. So tangential axis will be in this direction, in the same direction as velocity. Why? Because in the first chapter, I have mentioned that velocity is always tangent to the path. So kita tahu 3 meter per second here acting in this direction is the tangent of the path. So tangential axis will be pointing in this direction. Correct. Thank you. What about the normal axis? Normal axis is pointing in which direction?
Pointing to the origin.
Correct. Pointing to the origin, and it is 90 degrees to the tangential axis. So if you define tangential axis pointing this way, 90 degrees to the tangential axis and pointing to center O is the normal axis. So you have now AT pointing this way, AN pointing that way. Okay. So this completes our free body diagram. The red colored one is the free body diagram showing the forces. The blue colored arrow is the kinetic diagram showing the acceleration component. Okay. Now, what do we do? Now what do? We will apply the equation of motion lah in both axes. So we will apply the equation of motion in tangential axis, and also we will apply the equation of motion in normal axis. Let's apply the equation of motion in tangential axis first. Okay, so we have the total force in tangential axis is equal to MAT. Okay, and you see here the increase in speed of the ball at this position is defined by MAT, because AT is equal to V dot. Remember, V dot is dV over dt. So that is what it means by the increase of speed, dV over dt, the change of speed over time. So what we actually want to find here is AT lah. What is the value of AT? That will answer the first part, which is the what is the increase in speed of the ball at this position. Okay, so in tangential axis, how many force do you see? acting in tangential axis? How many forces are acting in tangential axis? mg, does it acting in tangential axis? Yes, the component of mg, right? Mg here is acting in is pointing down. It can be apa ni? It can be separated into components of tangential as well as component of normal axis for mg. For tension, it is acting only in normal axis. Jadi tension tak ada dalam tangential axis. So what you have in tangential axis is only the component of mg. So mg cos 45 degrees, you see here is 45 degrees, which means the angle here, the angle between mg and at is also 45 degrees here. Therefore, mg cos 45 is equal to mat. Okay, you see there are the mass on both sides. You can exclude the mass. Then you can have at is equal to 9.81 cos 45 degrees and at is equal to 6.937 meter per second square. That is the increase in speed of the ball at this position, at. Okay. Any question so far? Is this clear? How to get the tangential acceleration?
So far clear, sir.
Okay. Now, after we apply the equation of motion in tangential axis, then we will apply the equation of motion in normal axis. Okay, Fn is equal to MAN. And tadi kita dah bagi tahu AN is equal to V square over rho. So you can write Fn is equal to mv square over rho. Okay. What is rho in this case? What is the value of rho?
2 meter.
Radius of curve.
Good, betul, radius. So rho is equal to 2 meter. Dah diberi, so we don't have to calculate rho. What is the value of V? Kita tahu tak? Value of V.
3 sir.
3 meter, correct. V dah pun diberi 3 meter. Mass pun diberi 10 kilograms. So we have all the right hand side punya part. We only need to write what is on the left hand side of the equation. Okay, so go back to the free body diagram yang color merah, arrow color merah, and look at the normal axis. Look in the normal axis. What do you have in normal axis? We have the tension pointing in the same direction as normal axis. So tension will be positive lah. Tension will be positive. The mg component, there will be another component of mg pointing in the opposite direction of the normal axis. So which means that mg, the component of mg will be negative. And the component is mg sine 45 degrees. Because we say that over here is 45 degrees. So going in this direction will be mg sine 45 and negative because it is pointing in the opposite direction of the normal axis. Tension is pointing in the same direction as normal, so it will be positive. Okay, so T minus mg sine 45 is equal to m times 3 square, 3 is the velocity square, divided by 2, 2 is the rho. Okay, then we can get the value of T lah. M kita ada, G kita ada, and we can substitute all the values and bring this on the right hand side to get T, the tension at this moment is equal to 114.4 Newton. Okay, settle. So, ada apa-apa soalan? Any question on this? Clear?
Sir,
Yes?
I don't understand. It's stated that it moved along the vertical path, but why do we use mg?
Why do you use mg? Move along vertical path. Vertical path. Yeah. Vertical is like this kan?
Oh, okay, sir.
Kan?
Understand.
Vertical macam ni kan?
Yes. Maybe
Horizontal.
I confused with maybe negative and positive. Maybe.
Okay. Alright. So if there's no more question, let's go to the second problem. Okay. This is a slightly different problem where you can see now it is three-dimensional. This is just, I would like to show you what I mean by this three-dimensional case where we have the binormal axis equal to 0. The force in binormal axis equals to 0. So we are going to try applying these three equations to solve the second problem. Okay, let's read the problem first. A girl having a mass of 15 kg sits motionless relative to the surface of a horizontal platform at a distance r equals to 5 meter from the center. Okay, the girl is sitting at the edge of the circular platform 5 meter from the center. If the angular motion of the platform, so platform ni is rotating. Okay, you nampak the arrow, the blue arrow ni showing the rotation of the circular platform. Is rotating slowly, increase so that the girl's tangential component can be neglected. Okay, dia kata the tangential component of the acceleration of the girl can be neglected. So kita boleh assume equals to 0 lah. So therefore the only acceleration component yang ada pada this girl is only the normal component AN, which is pointing towards the center lah. Okay, determine the maximum speed which the girl have before she begins to slip off the platform. Maksud dia apa maximum velocity of the girl before dia akan terkeluar daripada platform ini, because of the velocity is too high, the girl will be will slip off the circular platform. And dia ada bagi tahu juga the coefficient of static friction between the girl and the platform is 0.2. So there is friction between the girl and the platform that to make sure that the girl is not slipping off the platform. Tapi bila the velocity becomes too big enough to overcome the friction, then the girl will be will slip off the platform lah. Okay, so first let's draw the free body diagram. What are the forces acting on the girl? Anyone? What are the forces that is currently acting on this girl?
Weight.
Weight, good. Of course, there is a weight. So let's draw the free body diagram. There must be a weight of the girl, okay, mg pointing down, and the girl is in contact with the platform. So whenever ada contact dengan ground ataupun contact dengan apa-apa sahaja, two objects in contact, there will be a normal force. Okay, so you can see here the weight mg is pointing down, normal force is pointing up, okay, on the girl. Lepas tu there is also coefficient of friction, so there must be friction force. Friction force is acting to the center point here, which is in the normal axis Okay, this friction is preventing the girl from slipping off the platform. Tapi apabila velocity is too big, too large, the acceleration is very big, then the girl will be slipping off the platform. Okay, the kinetic diagram, we have the tangential axis pointing this way and the normal axis pointing towards the center of the circular platform ni lah. Okay, so that will be our kinetic diagram. Okay, so what do we determine first? Okay, let's look at the mg and na. In which axis the weight mg and the normal force na is acting? In axis mana? Dalam axis mana dia sedang bertindak? mg dan na.
Z-axis.
Z-axis. What is the name of Z-axis tadi? Tak ingat. Z-axis ni dalam normal and tangential axis, this is normal axis, this is tangential axis, and this Z-axis is called the binormal axis. Okay, in Z-axis, we have shown before that the total force in binormal axis FB is equal to 0. Okay, sebelum ni saya dah tunjuk dalam slide ini. Okay, total force in binormal axis FB is equal to 0 because there is no motion in binormal axis. Okay, because when there is no motion in binormal axis, AB it will be equal to 0. Therefore, the right hand side of the equation equals to 0 lah. Okay, then let's go back to this problem. You can also see here in this case, the girl will not move up and down. Betul tak? Dia hanya akan move sama ada back and forth ataupun left and right sahaja. Dia akan move in either normal direction or tangential direction. It will the girl, she will not move in the binormal axis, in Z axis. Therefore, no motion in binormal axis, so total force in binormal axis equals to 0. So we can write by referring to our free body diagram, we know that NA is positive, mg is negative, so Na minus mg equals to 0. So we get the value of Na from this formula here. Na is equal to 147.15 Newton. Okay, this is our normal force acting on the girl. Okay, so how do we know what is the maximum speed which the girl have before she begins to sleep? Macam mana, apa keadaan yang nak mengatakan the girl will slip off the platform? How do you know that the girl will slip off the platform? What will be the condition? Anyone?
Lesser than static friction.
Okay, that's one way to know. But remember I said that whenever an object is in contact with the ground, there will be normal force Na. So apabila the girl is no longer in contact with the ground, will there be any normal force ataupun normal force dah hilang? Do you remember? Do you understand what I'm saying? If the girl is in contact with the platform, there will be normal force, Na. But when the girl is slipping off the platform, then the normal force will be equal to 0. Okay? But okay, let's look at the forces in normal axis first. Fn is equal to mv square over rho. Okay, so we can see that in the normal axis there is only friction. Friction is pointing in the positive direction of normal axis, so friction force is equal to mv square over rho. Friction force is equal to mu times Na. Na we have up here, okay, which is equal to mv square over rho. Okay, so we can substitute the value here, 0.2 times 147.15. Okay, ini yang kita dah dapat atas ni. Mass is 15 kg, mass of the girl. Rho is 5 meter. Okay, rho is the distance from the girl to the center, and therefore we can get the velocity is 3.13. Okay, when the normal force is still there. Bila normal force dah tak ada, means that the girl is already off the platform lah. Okay. So do you have any question on this example? This example is to show how we can use the binormal axis in z-axis here, fb equals to 0, to solve the problems related to normal and tangential component lah. Okay. Any question?
Sir,
Yes.
why mg is on the top of the surface?
On the top of the surface. How would you define mg? When the girl is sitting on the surface, of course the weight of the girl is acting downwards. Betul tak? You cannot define mg in the normal axis in this direction. It is not logic. Mg must be pointing downwards. Do you understand?
Oh, yes, I understand, sir.
Ah, okay. Mg must be pointing downwards. So we have to visualize the problem here. The problem here is a three-dimensional problem. So the mass must be acting down to the ground lah, to the earth. So this is the direction to the ground, downwards. So you cannot define mg in normal axis like this. Okay. Any more question before I go to the next example? Okay, let's look at the next example where we have the function of the path given. Okay, the function of the path given, and therefore you don't have the rho. The value of rho is not given, so we have to use the function of the path to find the value of rho. Okay, let's read the question first. Determine the maximum constant speed at which the 2 megagram. 2 megagram car ni sebenarnya berapa kilogram the weight of the car? Do you know? 2 megagram is equal to how many kg?
2000.
2000. Good. 2 mega is 2 million. Mega is 10 to the power of 6, and gram is 10 to the power of minus 3 kilogram. So 2 megagram means that the weight of the car is 2000 kilogram. Okay. Can travel over the crest of the hill. The crest of the hill is the top of the hill ni lah, at point A, without leaving the surface of the road. Apa maksud dia? Dia nak tahu what is the speed, maximum speed that the car can travel without jumping at the top of the hill. So if the car has the speed very high, by reaching the point A, the car might go up lah, sebab the speed is very high, then it can go up of the surface of the ground because of the very high velocity, very high speed. So the question here is, what is the maximum constant speed so that the car will stay in contact with the surface of the road. Maksudnya kereta ni tak akan melompat lah bila dia sampai ke puncak bukit A ni. Okay, so first we will draw the free body diagram. So what we want to know is when the car is at point A, not when the car is at this point. This is just showing a representation of the car. So when the car is at point A, what are the forces acting on the car? Okay, first we're gonna have the weight of the car, mg, and since we assume that the car is a particle, we will define only one normal axis, normal force NA. Okay, sepatutnya kereta it has 4 tires, so there should be 4 normal forces lah, but we are not going into that problem yet, because that will be covered in rigid body dynamics, which is out of our scope for this class. So we will consider the car as a particle only, so there will only be one normal force acting on the car. So altogether there are only 2 forces acting on the car. One is the one is the weight of the car, mg. The other one is the normal force of the car. We also need to determine our normal and tangential axis to define the kinetic diagram. Okay, so in which direction is the tangential axis and in which direction is the normal axis? Anyone? Tangential axis is pointing to which direction?
Horizontal.
Horizontal direction. Ke kiri ke kanan?
Kiri.
Ke kiri, correct. The car is travelling in counterclockwise to the left, so the tangential component will be pointing to the left. Okay, and therefore 90 degrees to the tangential component will be the normal component of the acceleration, which will be pointing to the center of the arc. So ini arc dia, center of the arc will be somewhere down here lah. Okay, so that completes the free body diagram. The blue colored arrow is the for the free body diagram. The kinetic diagram is the green colored arrow. Okay, so if the car is about to leave the road surface, the normal axis will be equal to 0. This is similar to what I have explained in the previous example. If the car is no longer in contact with the surface, maksudnya kalau dia terlalu laju sampai pada top of the hill, the car is jumping, then NA is equal to 0. So this is our condition here. We want to determine what is the maximum speed that the car can have to in order for the normal axis to be equal to 0. Okay, now let's look at the axis where we have all the forces here. We have the forces in normal component, normal axis. So we are going to focus on the normal axis only. Okay, the total force in normal axis is equal to mv square over rho. This is what we have defined before. And rho is unknown, it's not given. What is the value of rho, which is from this point of the car to the center of the arc? Maybe somewhere down here, but we don't know what is the value of rho. So therefore we have to use the equation. I have shown this equation also in the previous slide. Rho is equal to 1 plus dy dx square to the power of 3 over 2 divided by d2y over dx square. Okay, so we have the equation of the path here. Y is equal to 20 times 1 minus x square over 10,000. So we need to get the derivatives of this function. So what will be dy dx of this function? Anyone? Dy dx of 20 times 1 minus x square over 10,000. What will be the dy dx of this function? Berapa? If you differentiate this function, dy over dx, on the right hand side akan jadi apa?
Sir, is it 0?
What do you mean 0?
The value of dy dx.
No. If you differentiate dy over dx, what will be on the right hand side?
dy dx equals to x over 250.
X over 250. Macam mana you dapat x over 250?
Depan ada tambah negatif.
Negative x over 250.
Yes.
Okay. Dy dx is equal to minus 2x over 10,000. Betul ke? Betul ke jawapan you? Macam mana jadi 250 Okay, let's do it like this. You multiply semua 20 ni masuk dulu. So you will have y is equal to 20 minus 20x 20x square over 10,000. Betul tak?
Betul, sir.
Okay. Oh, jawapan saya ni salah saya rasa. So, when you have 20, dy dx of 20, 0 lah. And then you have dy dx of 20x square over 10,000. So, you akan jadi 2 kali 20. So, which is 400 divided by 10,000. Jadi, 1 over 250 ke? Sekejap saya calculate. Saya rasa jawapan saya yang salah ni. 40 divided by 10,000. Okay, you get 0.004, right? Yep. Okay, my answer is wrong. Please correct this. It should be minus 40 kat sini, bukan 2x ni. 2x it should be multiply with 20. Saya lupa nak multiply with 20. So it should be 2 times 20. So 40 lah. 40 minus 40x over 10,000. Betul kan? Minus 40x over 10,000 for dy dx. For d2y over dx square, you will differentiate once again this one. So ini pun salah ni. It should be minus 40 over 10,000, bukan minus 2. Minus 40 Please correct this. Nanti kalau you salin jawapan ni, please correct this. This should be minus 40x over 10,000. This one should be minus 40 over 10,000. So this will be dy dx and this will be d2y over dx square. Okay, then once you have all this, you can substitute in the value lah. What we want to know is at x equals to 0. At this point, x is equal to 0. X is 100 over here. Here is x equals to 0. This is the coordinate given. Okay, xy coordinate. So at x equals to 0, rho will be 250 meter. 1 plus 0, you key in 0 in here, will be 0. And then down here, it should be 40 minus 40 over 10,000. And remember this, the expression down here is in the modulus form, ataupun in absolute form. Maksud dia, you can ignore the negative sign down here. Bila you ignore negative sign, it becomes 0.004. So rho akan jadi 250 meter. Okay, once you have the value of rho, then you can substitute in this equation here. Okay, kenapa tinggal mg sahaja? Because NA is equal to 0. Kita dah bagi tahu atas ni, if the car is about to leave the surface, NA is equal to 0. So, NA is in the negative normal. Normal axis is acting downwards. Nampak AN is acting down. So, mg yang positif. Therefore, mg is equal to m times v square over rho. So, you can ignore ni, m boleh potong. So v square is equal to g times rho, and you can square root to get v is 49.52 meter per second. So this will be the maximum speed. So kalau kereta tu drive at 49.52, sampai atas ni dia akan melompat. So it should be lower than 49.52 meter per second lah, to make sure that the car will stay on the ground when it reach the top of the hill. Okay. Do you have any question? No question?
No, no, sir.
Okay. If there's no question, then let's go to the last example. This will be the last example for today before we end the class. Okay. The 2 kg pendulum bob. Okay, bob ni bola ni lah, bola yang connected to the rope here. The whole thing ni, tali dan bola, kita panggil pendulum. The ball alone is called the bob. Okay, the 2 kg pendulum bob moves in the vertical plane. Okay, moves in the vertical plane with a velocity of 8 meter per second when theta equals to 0. Okay, ni sama macam tadi siapa yang tanya tadi. Vertical plane means that the weight will be acting downwards lah. Bukan kita pandang dia as it is. Bukan pandang dia daripada atas. Bukan pandang dia three-dimensional from top. Okay, bukan top view. Determine the initial tension in the cord, and also at the instant the bob reach theta equals to 30 degrees. So apa yang kita kena cari dekat sini, we need to find what is the tension in the cord at two position. One is at this position when theta equals to 0, the initial tension here, and then after the bob has traveled to 30 degrees, what is the tension at this moment. So dua tension we need to find. Okay, let's first look at the initial tension in the cord. Initial tension means that we only have to look at the first position, the horizontal, the cord in horizontal, the pendulum in horizontal position only. Okay, now we draw the free body diagram. Okay, we have the weight of the bob pointing down, and we also have the tension. Okay, tension dalam cord ni will be pointing towards the center of the ni lah. Okay, what about the axis? In which direction is the tangential axis, and in which direction is the normal axis? Anyone? Tangential axis, in which direction?
Tangential axis will be to the top, and for the normal will the same direction as the tension.
Okay, good. Thank you. So the tangential axis will be pointing up. Okay, will be pointing straight up, and 90 degrees to the tangential axis will be the normal axis. So normal axis will always pointing to the center, and 90 degrees to the tangential axis. Okay, so now at theta equals to 0, so we are looking at this horizontal position lah, at theta equals to 0, total force in normal axis. We only focus on normal axis because we are interested in finding the tension. Okay, tension ni tak ada dalam tangential axis. So we don't even need to look at the tangential axis pun. Kita tengok the normal axis sahaja. Fn is equal to mv square over rho. Do we know what is the value of rho?
2 meter.
2 meter is the value of rho, the distance from the bob to the center, 2 meter. Do we know what is the value of v at this moment?
Given 8 meter per second.
Yes. When theta equals to 0, the velocity is 8 meter per second. So it is also given. The mass we know, and what we don't know is only the tension. So when we write the equation, T is equal to 2, the mass, times 8 square over 2. So we have the tension, initial tension is 64 Newton. Okay, that is the first answer of the question. Okay, let's go to the second problem. The instant the bob reach theta equals to 30 degrees, we want to also find what is the tension when the bob is in this position. This position is a new position, so we need to draw a new free body diagram. In which direction is the weight acting now when the bob is in this position? Direction of weight dekat mana?
Downward.
Downwards ke sengit sikit macam ni?
Same as the previous mg.
Good. Remember, the weight will always downwards. Dia tak akan bertindak pada angle. So, mg will stay downwards, but the tension now is following the chord lah. The chord is now in this direction, so this will be the tension. So, this is the free body diagram for the second position of the pendulum, of the bob. What about the tangential and normal axis now? In which direction is the tangent and in which direction is the normal?
Tangent downward.
Tangent downward sama macam mg. Macam tu ke?
Component of weight.
Component of weight. Maksud dia hala ke sini?
Yes, sir.
Okay. Normal?
To the center of the circle.
Okay, normal follow tension lah. Okay. Tangential is not correct, tapi normal tu betul. Normal is following the tension to the center of rotation ni kat sini. Tapi the tangential component is pointing that way sebab the pendulum is still moving. The pendulum is still moving, dia still rotating macam ni. Kalau you boleh imagine, dia rotate in counterclockwise, lawan arah jam. Okay, dia rotate counterclockwise, dia masih rotate macam ni. So tangential axis will be pointing up lah, tangent to the path here. Normal akan jadi 90 degrees to the tangent, pointing to the center. Okay, so normal ni sama arah dengan tension. Tangential axis will be pointing up this way. Okay, so we have theta dekat sini, which means that dekat sini antara mg dengan tangential axis ni is also theta lah, the same angle kat sini. Okay, alright. So now we are talking about the second position at theta equals to 30 degrees. Let's look at the forces in tangential axis dulu. How many forces do we have in tangential axis? Do we have the tension in tangential axis?
No, sir.
No, we don't have tension in tangential axis, but we have the component of weight mg ni kita boleh pecahkan dalam normal, dalam tangential axis and also in normal axis. So in tangential axis dia akan jadi mg cos theta multiply with cos theta, and dia the direction is the opposite of tangential axis. That's why it becomes negative. Okay, negative mg cos theta is equal to mat. Okay, so ni boleh potong, and then you have at is equal to minus 9.81 cos theta. Okay, minus 9.81 is g lah, 9.81 cos theta. We can substitute 30 degrees dalam theta ni to get what is the actual value of at, but I'm not gonna do that because we need to do something with this in form of theta after this. Okay, I will show you why and how to do it. Now, kita tinggalkan ini dulu because we want to go to the normal punya component. Okay, normal. Fn is equal to mv square over rho. Let's remember what we want to find here is the tension. Kita nak cari apa tension yang bertindak pada chord ini pada ketika theta equals to 30 degrees. Okay, in this case, Fn, we have two forces. One is the tension, positive, and we also have the component of weight. Component of weight ni, satu tadi kita dah pecahkan ke tangential axis. The other one, we can also write it in the normal axis, which will also be positive. Dia akan bertindak dengan di arah positif, sama dengan tension. So we have T plus mg sin theta. Okay, kalau dekat sini dia cos theta, dekat sini dia akan jadi sin theta, is equal to mv square over rho. Okay. And then we do some rearrangement. T is equal to, kita bawa mg sin theta ni ke kanan. So we have mv square. M ni ialah 2 kg. V kita tak tahu. V 8 meter per second is given at the initial position. Bila dia dah sampai ke position ini, V dia dah berubah. Tapi kita tak tahu berapa V dia. Okay, so we have 2V square over 2. 2 is the rho minus mg sin theta. 2 times 9.81 sin theta. Then we have T is equal to V square. 2 dengan 2 ni hilang. Minus 19.62 sin theta. Okay, from this relationship, you know that, you can see that to find the tension, we need to know what is V. What is the value of velocity? Okay, to find tension, we need to know what is the value of velocity. Okay, this is what we have so far. We have AT is minus 9.81 cos theta, and we have T equals to V square minus 19.62 sin theta. How do we get this V here? Macam mana kita nak dapatkan V so that we can get the value of tension? Do you have any idea how to get the value of V? Any idea? Tak ada idea? Okay. When you reach the point where equation of motion cannot solve the problem, then you know that you may have to use the equations from chapter 1. Maybe you have to apply kinematics equation. Sekarang kita tengah belajar kinetics, those yang related to force. Tapi sekarang ni you nampak, oh kita perlukan velocity. We need the value of velocity. Velocity is kinematics, the characteristic of motion. So when we need the value of velocity, you know we need to apply kinematics punya equation. Okay, from chapter 1, we know that V is always tangent to the path. Okay, V is always tangent to the path, meaning that V is only related to AT. Dia tak related to AN because AN is not tangent to the path. AT is the one that is tangent to the path. Okay. So from chapter 1 also, we know that we know a few basic equation. Kita tahu V is equal to ds over dt, A is equal to dv over dt, and there is one more kinematic equation that V is V dv is equal to A ds. Kalau you tak ingat mana datangnya ini, you can go back to our first chapter where I have explained about this. This is one of the basic kinematics equation. Okay, so to help us finding the value of V, we need to use this equation. Tapi, you tengok, kita sekarang ni, kita punya variable is theta. Kita punya, the things that is changing here is theta. This is the one that we have. But not the S, not the displacement, but the theta. So how do we relate S to theta? Do you remember there is one equation that relate S to theta? Siapa ingat? The equation that relate S to theta. Tak ingat? Anyone? Are you familiar with S is equal to R theta? Pernah dengar tak equation ni? Ada kan? I have also shown this to you, I think, in chapter 1 also. So this is the relationship between the displacement S and the theta. Okay, this is the relationship between displacement and theta. So, from here, what is the value of R here? Kalau kita tengok kepada problem ini, what is the value of R? 2, correct. So, we can then write S is equal to 2 theta. Okay. And we can also change this ds here to become d theta. Okay, you simply bring 2 theta into S here because you have defined S here equals to 2 theta. So to get the value of velocity, we need to integrate lah because we have dv here. So we have to integrate v dv. When we integrate left hand side, we have to integrate also the right hand side. So we integrate right hand side, at 2 times theta becomes d theta. Okay, theta becomes d theta. Do you clear until this point? Ada siapa-siapa yang tak jelas tak? Macam mana boleh dapat sampai sini? Is this clear?
Clear.
Okay. So basically, I repeat a little bit. We take this equation from kinematics, V dv equals to A ds, and we use S equals to R theta to get S equals 2 times theta. And then we replace S here with theta lah, with 2 theta. So you get V dv equals to AT times 2 d theta. Okay. Then to get the value of velocity, we integrate left and right hand side of the equation. You integrate left hand side, you have to integrate also right hand side. Okay. When we want to integrate, we need to know the range. What will be the range to integrate for velocity? Range ni mesti daripada initial kepada apa yang kita nak sekarang. So, for velocity, what is the initial velocity?
8.
Good. Initial velocity is 8. So you integrate from 8 until berapa? You don't know. You don't know what is the velocity at theta equals to 30 degrees. So you integrate from 8 until v because the v at 30 degrees is still unknown. So this will be the range for left hand side integration. What about the right hand side integration? You integrate now d theta. It's not dt, not the time, but now the angle d theta. So you integrate from what is the initial angle until what is the current angle. So what is the range?
0 and 30.
0 to
30.
good. 0 until 30 degrees. Okay, so this range of integration ni you have to be able to extract lah daripada problem. So when you see the problem, you should know what is the range, what is the initial value, what is the current value that you want to calculate. Okay, so now you have integration of v dv from 8 until v. Kenapa 8? Because initial velocity given here 8 meter per second. And then right hand side is integration of AT times 2 d theta from 0 to 30 degrees. Kenapa 0? Because initially theta equals to 0 and then it moved up until here theta equals to 30 degrees. Okay, so this is the basis of what we are doing here. Okay, so when you want to integrate AT, you go back to up here. Kita dah ada dah kat atas ni. AT is equal to minus 9.81 cos theta. Okay. So all the constant you boleh bawa keluar. Okay. You keluarkan minus 9.81. You keluarkan 2 ni. Bring to the front. Okay. Then what you integrate is only cos theta. Cos theta d theta. Okay. This will... you akan nampak integration dia simple dia sebenarnya. If you have all this thing inside, maybe it will make you confused lah. So you bring all the constant yang tak ada variable outside of the integration. So basically you are integrating from 0 to 30 degrees cos theta d theta. Okay, so let's look at left hand side dulu. v dv, you integrate v dv, what do you have? Integrate of v dv is equal to apa? Anyone? Integrate v dv. You akan dapat v square over 2, right?
Yes, sir.
Yes. Okay, jangan confuse. You may be familiar with integration of dt. Tapi dia sama je. If you integrate v dv, then what you get is v square over 2. And the range is from 8 to v. Ni range yang kita dah define tadi. Okay. Right hand side. Integration of cos theta, you akan dapat sin theta. Positif. Kalau you integrate sin theta, you akan dapat negative cos. Okay, so this is trigonometry punya integration. So integrate cos theta, you dapat sin theta. And then, yang kat luar ni, you just simply multiply lah. Minus 9.81 times 2, you dapat minus 19.62 sin theta. And then the range is from 0 to 30 degrees. Okay, from 0 to 30 degrees. Alright, now, on this side, bila you key in the value, you will get v square over 2 minus, you masuk 8 pula, 8 square over 2. Okay, so this is the left hand side. V square over 2 minus 8 square over 2. On the right hand side, what you have is minus 19.62 sin 30 minus 19.62 sin 0. Okay, this is what you have on the right hand side and left hand side. Ada soalan tak setakat ni? Ada siapa-siapa yang tak ingat ke macam mana nak buat integration ni? You boleh bagi tahu. I can explain if you want me to explain. Semua jelas tak sehingga sini?
Jelas.
Jelas Okay. So basically what we did was kita integrate the left hand side and kita integrate the right hand side and we have the range. So sekarang kita key in the range. So v square over 2 minus the lower range 8 square ganti dalam v 8 square over 2. Same goes for the right hand side. Sin ni kita key in the upper range sin 30 minus key in the lower range sin 0. Okay, so this is what we have until now. V square over 2 minus 8 square over 2 is equal to minus 19.62 sine 30 minus 19.62 sine 0. Sine 0 is equal to 0. So basically this term will become 0 also lah. Okay. Okay, so bila kita dah tahu yang ni 0, kita boleh rearrange then to get the value of V. So you just do some rearrangement. You boleh bawa 8 square over 2 ke kanan and then multiply by 2 and then you square root untuk dapat V equals to 6.662 meter per second. Once you have the value of V, you can substitute it back in this equation yang T ni, equation yang T ke atas ni, to get the value of T lah. So T at theta equals to 30 degrees is equal to, you substitute the value of V tadi, 6.662 square ke atas ni minus 19.62 sin theta ni 30 degrees lah. Theta at 30 degrees. So you will get T equals to 34.57 Newton. Okay. Ada apa-apa soalan? So the last example is showing a little bit complicated problem lah, but I think it's not that complicated. I hope you can understand how to solve this. So basically we have two stage of motion. Yang pertama pada initial condition, and then apabila dia dah bergerak sedikit ke atas, and you need to find what is the value at this moment. Okay. Do you have any question?
Sir,
Yes.
AT tu memang akan ikut pergerakan bola tu
Betul. AT akan ikut pergerakan bola.
Okay. Thank you.
Ada lagi soalan lain? Tak ada? Okay. So if there's no more question, that will be our class for today. So we have learned about the use of anti-components in Newton's second law of motion. Sebelum ni kita tengok Fx equal to max, Fy equals to may. Hari ni kita dah tengok Fn equals to man, which is mv square over rho, and Ft equals to mat. And then we have used anti-component to solve problems related to kinetics of particle in curvilinear path. Okay. So if there's no more question, I would like to thank you for coming to the class today. Let me snap the attendance first before you leave. Okay, there's one more thing I would like to discuss with you about the quiz. So we will finish with chapter 2 by this week. Hari Rabu ni will be the last class of chapter 2. And next week will be the mid-semester break. So my question is, do you want to do quiz on this coming Wednesday, atau you want to do it during the mid-semester break?
Mid-semester.
Yang lain macam mana?
Sama saya.
Mid-semester break Okay. If you decide to do if you decide to do during mid-semester break, nanti kita discuss balik dalam WhatsApp group lah, hari apa yang sesuai dan sebagainya, waktu bila, because during mid-semester break you tak akan ada kelas kan. So maybe kita boleh buat waktu petang ke waktu malam based on your preference lah. Nanti kita discuss. When you come back from mid-semester break, week number 8 on Monday, we will have test 1. About test 1 nanti saya akan explain further dalam WhatsApp group lah. Okay? Alright, so again, thank you for coming to the class, and I will see you again on Wednesday. Assalamualaikum and have a good day.
Waalaikumsalam.